Thank you for downloading this podcast on 702.co.za or capetalk.co.za.
Some respect the property of others. What are you doing to lead us in?
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
Time for The Naked Scientist, of course, and The Naked Scientist is brought to you by MWeb. MWeb, connect and you can. Hi there, Chris.
Hello.
I was going to ask you how you are, but the answer is can't complain.
Yeah, we're all following Thomas's mantra now.
Absolutely.
He should be a politician. He can get everyone towing out the party line. Trotting out the party line, even.
If you've just tuned in, it is, of course, The Naked Scientist on the line. All your questions, why don't you give us a shout on 011-883-0702 in Joburg, and in Cape Town, your questions for The Naked Scientist. We're going to take them on 021-446-0567. Now, I think, I believe you've got a very fascinating story to share with us, Chris, about techniques we might borrow from fireflies to have brighter LEDs. That sounds fascinating.
Yes, Eusebius. There was a paper in the journal PNAS, Proceedings of the National Academy of Sciences, from Korea, which caught my eye. A very illuminating paper, you might say, because it's all about fireflies. And what this group at Korea's Advanced Institute of Science and Technology have found, they went looking at fireflies, and they were looking at the surface of the fly's skin or cuticle with an electron microscope. And they found that over the main part of the insect's abdomen, the surface cuticle was thrown into a series of undulating folds with no obvious pattern to them. But then when they looked under the microscope at the part of the insect's abdomen that makes the light, the firefly's actual lantern, they found things were dramatically different. And the surface of the cuticle was in this very organised, straight series of ridges and folds. And when they measured them, the heights of these ridges was about 1/7,000th of a millimetre tall, each of them. And that means that it's about the right size to be about a quarter of the wavelength of the light that's coming out of the insect. And you think, why is that important? Well, if you've ever seen a camera, when it's reflecting light back at you from its lens, you'll see the lens has a sort of greeny-purple sheen on it. That is because on the surface of the lens, the anti-reflective coating is a thin layer about a quarter of the wavelength of light. And this stops reflections going back into the camera from inside and back out again. And that would blur the image otherwise. So what it has the effect of doing in the firefly is making the light come out and very efficiently get coupled to the air so that the light can come through very efficiently. So they wondered if they copied this design, would it produce LEDs that, or other light sources that would work better? So they made a little silicon model of this pattern of ridges and folds with light to etch silicon. And then they used the silicon as a mould, and they poured some plastic into it to create a contour which was, at the nanoscale, identical to the back end of a firefly. They put that onto an LED, and they immediately got an LED that was 3% brighter than it had been before.
That's fascinating.
So just by taking an idea that nature has refined through evolution over millions of years and then applying it to modern-day technology in one easy step, they immediately got what amounts to a pretty dramatic increase in efficiency. So they're now saying that this could be used for the next generation of LEDs to make much better and superior performing LEDs that are even more efficient.
Your questions for The Naked Scientist, 011-883-0702 in Joburg, and in Cape Town, do call in on 021-446-0567. These being modern times, feel free to also tweet a question, and I'll happily read it from there, or SMS, of course, if you're that old-fashioned, 31702 or 31567. A fabulously selfish question for you, Chris, coming from Greg. Hello, Greg.
Hi, good morning. I just wanted to know, what are the benefits of donating blood to your body?
Hi there, Chris.
Greg, did you say donating blood or making blood?
Donating blood. You know, when you donate blood, is it a good thing for your body or?
Well, some people have suggested that the answer is yes. Because when they went and had a look at the data on people who gave blood, they found that people who tended to be blood donors also tended to live a lot longer. Now, you could conclude, therefore, that giving blood must therefore make you live longer. But actually it may be a statistical flaw in the sense that if you take a group of people who give blood, the people who by definition give blood are more likely to be healthy on average than people who don't give blood. Because if you give blood in order to give blood, you have to be healthier, because there are various rules and regulations, and people who are really sick are not going to be able to give blood anyway.
Is that a different way, Chris, of saying unhealthy people are generally more selfish?
Exactly. You could make the same statistical mistake if you weren't careful. So, on the one hand, it could just be numbers, in the sense that we're picking out people from the population and turning them into blood donors, and because by giving blood they're probably healthier anyway, that may explain the longevity effect. But then there is also potentially a biochemical argument, which is that women are relatively protected from things like heart attacks until the menopause. Of course, at the menopause, that's when their periods stop. Up until then, they're therefore shedding some blood every month, and blood contains iron, and therefore women are relatively iron poor compared with men who are relatively iron replete. And iron is an important catalyst in a number of chemical reactions in the body which produce what we call reactive oxygen species and peroxynitrile. And there's one of these reactions called the Fenton reaction, which is thought to produce these reactive oxygen species and can damage tissues and cells. And so one argument is that because men have more iron than women for longer, that they are more likely to have these reactions going on, and this could injure tissue and therefore make them age faster than women, which is why men might not live as long as women, and that giving blood effectively makes all the population have slightly less iron, which is not a major health issue because you can quickly make up the blood, but it does reduce the risk of you having these other chemical reactions going on that damage or age your tissues.
Dale, your question.
Hi there. Maybe a silly question, but I've always wondered to myself, the water on Earth is the same water that was here millions of years ago. We don't get new water every month from outer space or anything like that. And companies then extract it from underground, and they sell it as bottled water. And it's been under the ground for millions of years, but they put an expiry date on it. Why is that? Why do you...
It's absolutely daft. It's like the person who said, why is my salt, my sea salt, why has it got a best before date? This is just sodium chloride. It's the same stuff that's been on Earth for millions of years. Don't know, Dale. I think it's probably down to regulation, that anything that you package up for human consumption appears to attract legislation. And that legislation is you've got to have a best before date on it. Of course, there are things that could change, and we've had the conversation before on this programme about what plastic bottles might do for water, because most water that you buy in the shops now, for convenience and for weight, because transporting heavy glass bottles is bad news, because it costs a lot of transport costs, the bottles break and so on. So a lot of companies use plastic. Problem is plastic leaches chemicals called plasticizers into the contents of the water bottle, and these plasticizers can have a range of effects, including mimicking female hormones, which can have health effects on both men and women, and also getting into the environment where they can do other things to other members of the environment, including animals. So,
if you just tune in,
to stick to glass.
Yeah, we are chatting to the Naked Scientist. Don't you just love his brain? Starts off answering, I don't know, and then proceeds to enthrall you with all sorts of facts anyway. If you're in Cape Town, give us a shout on 021 446 0567. And of course in Joburg, 011 883 0702. Harold in Midrand.
Yes, good morning. So I just want to know, if the Earth was able to be put onto a scale when it was first created, and you put it on the scale today, should it not be exactly the same weight, with the exception of the human beings, because everything else on Earth actually comes from the Earth anyway?
Hello, Harold. The Earth weighs, we think, that's wrong, I should be careful, naughty, slap on wrist. The Earth has a mass of 6 times 10 to the 24 kilograms, give or take. So in other words, 6 followed by 21 zeros in tons. You used the phrase when it was first created. I'll just slightly tweak that. So when the Earth first formed, it was created out of the dust in a protoplanetary disk. And this was a slow process of the dust and other grains and particles slowly coalescing together, initially into what we call planetesimals, baby planets, which then merged together to form bigger bodies. And some of those coalesced into what we now see as our inner rocky planets, one of them being the Earth. So when the Earth first began to form, it was tiny and made of dust, so its mass has obviously increased since then, because under the influence of gravity all this other material has come together. But then, during the Earth's early history, it wasn't as wet as it is now. It did have some water, because we now know that there was water in that patch of the protoplanetary disk, but a lot of water has arrived on the Earth since then, and it has arrived in the form of delivery in comets and also chiefly aboard asteroids. And so the Earth's mass has changed dramatically over its lifetime. Initially it weighed, or had a mass of 0 because it didn't exist. Then it began to form from tiny grains, and it would have slowly accreted those to increase its mass yet further. And then it's had other bombardments and asteroids coming in, which have delivered water and other stuff to the Earth. And then we're at a position where we find ourselves now, which is that there are several inputs and outputs. There are light things like hydrogen, which is escaping from the Earth all the time. We're losing hydrogen into the space. Thousands of tons every year of hydrogen gets lost because we can't hold on to it. Same for helium, but there's not very much of that around. Then there's the inputs. We've got stuff coming in. We've got dust and particles and bits of asteroid raining in as tiny dust particles onto the Earth all the time. And we think between 40 and 50,000 tons of that stuff lands here every year. And then there's another interesting source of energy, which is solar input, because if you look at global temperature trends, the Earth's system is getting warmer year on year by a small amount. If you're making something warmer, the system must be getting more energy. In other words, the sun's energy is coming in and it's not leaving, so there's a net increase in temperature. If you add more energy to the system, because E equals mc squared, Einstein's equation, if the E energy is higher, the c squared bit doesn't change because the speed of light is the same, so the mass must go up to compensate. So the Earth is gaining some mass every year because it's getting warmer because of global warming and energy input from the sun. Now, the people on the Earth, which was the final part of your question, that is not part of the equation, because the people on Earth are made from the same substance that the Earth is. We just take materials out of the environment and we coalesce them together into a big bag of chemical reactions that we call a human, but the materials come from the Earth, and therefore we haven't made ourselves out of something external to the Earth, so we're part and parcel of the Earth system, and therefore we haven't changed its mass. Irrelevant number of people, it's irrelevant however many people there are on Earth.
Okay, taking more of your questions for the Naked Scientist on 011 883 0702 and in Cape Town 021 446 0567. More of your calls right after this. 13 minutes before 10, the Naked Scientist is on the line, 011 883 0702 if you have a question for him, and of course in Cape Town 021 446 0567. Let's go to Centurion. How's it, Peter?
Good morning. I just wanted to ask a question in regards to interstellar probes that we send. Do we cross-contaminate the solar system by means of sending things like the Mars rover to Mars? And, do we sanitize them before we send? And is there perhaps a problem with anaerobic or aerobic bacteria maybe, taking over the planet that we put there?
Hello, Peter. What a brilliant question. And yes, the answer is that enormous caution is applied in this situation. We actually did a programme on the Naked Scientists in this country, in the UK, a few months back when Curiosity, the mission to Mars, touched down on the Martian surface, and we got on to NASA and asked them to clarify exactly what they do to make sure that these probes are not contaminated. And there is quite an interesting piece from them. If you go to the Naked Scientist website, nakedscientist.com/podcast, if you scroll down to the programme that says Curious About Mars, in that programme, which is fully transcribed on the site, you can download it for free and everything, there is an item there explaining exactly what steps NASA operate under. But the answer is they are very careful, because the one thing we don't want to do is to go to a million, to something millions of kilometres away, look for traces of life, and immediately contaminate the thing we're looking at with life, because then, of course, it's going to throw all of our readings off the scale, because anything that we take there is going to be far more prolific and common, at least initially in the area we're looking, than what might be lurking there in the vestiges of the Martian surface. So the answer is that they take as many steps as they can to make sure they don't have a mistake. That said, there's always room for a margin for error. And what we're finding is that some of the bugs that live on Earth are extremely tough, very hardy things. And it looks like they probably could survive a journey in space. We've had things called tardigrades, these little soil organisms, exposed to the vacuum of space for quite a long period of time in a NASA experiment, and they all survived, actually. We've also had bacteria, which are quite happy in space for limited periods of time. The thing that tends to get them is the radiation, but if they can be shielded from that, then they usually can survive. So there is a concern. We need to be careful, and people do take steps.
Hello, Gordon.
Hello, CBS. Fascinating questions. My question is, has the gravitational attractive force, the force of gravity on the Earth, always been a constant? Or is the Earth expanding and therefore the gravitational attractive force decreasing? Background to this is we hear of small dark planets, heavy planets that have a higher sense of gravity. Can the naked scientist explain?
Good morning, Gordon. Well, gravity is all about mass, and things have a gravitational effect on their local area owing to their mass. So the more mass something has, then the more gravitationally active that it's going to be. So if the Earth changes its mass, then its gravitational influence is going to change. If you look actually at a higher resolution at Earth, in fact, the Earth is not constant in terms of its gravitational field over all of its surface. And we can actually use this to our advantage. There are various missions that are now flying in space with satellites which are using what's called interferometry in order to register this. There's one quite famous satellite called GRACE, and GRACE is a pair of satellites whizzing around, and they are beaming between them a light pulse. And because one is a certain distance ahead of the other, when they're flying around the Earth, one is going to feel an increase or a decrease in any gravitational effect before the other, and this will have the effect of accelerating one of them slightly before the other one, and so the light pulse will change its journey time, and this can be used to calculate the overall gravity of that bit of the Earth's surface. And because the probe is going round and round the Earth, it's mapping the surface in this way, and in this way scientists have been able to analyse and weigh how much ice mass there is, for instance, on Greenland, and how much ice it's losing each year. And it comes to hundreds of thousands it comes to thousands of cubic kilometres. It's huge amounts of water that are being lost from Greenland every year, and they can do that just by working out the gravity changes. So we actually can do this quite well, and the Earth's gravitational field is different over its surface owing to different densities of different materials as well, and even water. The presence of Antarctica down in the south of the planet has a huge amount of ice there, and this attracts a bulge of water onto the surface of the planet, and so the water level is there owing to gravity being slightly different, and if we melt the ice away, then that's going to change sea levels elsewhere on the Earth.
There was a question earlier, Chris, about the mass of the Earth, which you ever so subtly reframed away from the creationism assumption. Well, here's a question from Lerato that will get you back into it. She says, hi, can you please ask Chris if it's possible that the Earth could have been created in 6 days, as the Bible claims?
It depends how you define a day, of course. We call a day 24 hours. If you were to go to Mars, a day is a totally different length of time, and if you go to Venus, a day is a totally different length of time. So I suppose your definition of a day was right. You could actually argue the Earth was made in 6 days, but certainly not in 6 Earth days. It was about 4.5 billion years ago that the Earth began to form, and it took millions of years to accrete the dust and debris together to actually form the planet. So it's certainly not something that can happen quickly.
Okay, unless you have the gift of interpretation, the answer is no, Lerato. Let's go to Vereniging. How's it, Trevor?
Oh, hi, CBS. Hi, Chris. After all this heavy science and physics stuff, I've got a very silly little question, probably. I just wanted to know if Chris could explain why small children don't need to use deodorants.
Hi, Trevor. I don't know.
They don't smell.
Sort of do. Yes, I mean, it's that they don't smell in the same way. I think that I think that there's a number of reasons, but I'm going to give a sort of fairly woolly answer. So please, everyone, feel free to correct me if I get this wrong. I think that the reason is that they don't sweat as much as older people do, and older people sweat more, and the thing that makes you whiff when you get sweaty is actually not the sweat but the bacteria that you nourish, because living on us and in us are huge numbers of microorganisms, and the skin nourishes a massive thriving community of microbes, and underarms and in other places are ideal places for them to grow because they're warm and wet. So the microbes live on the skin surface, they dine on us, so dead skin is their food source, and the sweat and the warmth keep them in a nice, an ideal environment to grow. And adults have quite a different microbial community to young children, and I think as we get older we establish this fingerprint microbe spectrum on us, and they then tend to make us sweaty. Kids also don't do as much and don't sweat as much, whereas adults sweat more, do more, and weigh more, bigger, producing more heat. And I think probably all those things sum together, because effectively it's a size thing as well. I reckon that's another important issue. If you've got a child, there's much less surface area for these bugs to grow on, whereas if you're an adult, you're much bigger. So the sum total of bugs can also be bigger, so you've got more whiff factories, more whiff.
Okay. Coffee, good morning.
Yes, good morning. Eusebius, great that you picked that up. The slight difference between forming and creating. I want to take on the naked scientist. He's got to tell us today why is he so afraid of using the term create as in using the term form. I'm no churchgoer and I love science. I'm always on science. There is no fear for him to use the term create in the sense that, because he said it already, we don't know. Even if it was created, why not use the term create? What is this fear of using the term create?
Hi, Coffee. What I was trying to avoid is an insinuation that the Earth got made all of a sudden, because the formation of planets is a long drawn-out process that doesn't happen overnight. If we create something, it tends to give the impression that it pops into existence, and we know that that is not how planets actually form. Our modelling studies and other data that we've got show us that you have a big ball of gas and dust which coalesces to form a proto-star, which is going to become, in our case, the Sun, and then around that is a shroud of material that slowly coalesces into initially a disk, rather like one of those throwing disks, around the waist of that star, and out of that you then slowly accrete material that's going to become planets. And this is not something that just gets to happen one day. It takes a really long time, and what I didn't want to give the impression is that this is just something that, snap your fingers and you've got a planet. It's something that takes a really long time to happen.
I agree with you, but still, you just put your finger on it. In fact, in your own eyes, you say in modeling practices and exercises, who is modeling? There's got to be somebody putting that modeling thing together with his hands or his thoughts or whatever it is. Just a form of creation. Even modeling by itself becomes a form of creation. You can't avoid that. And the ability to run away from the idea of saying, well, it just popped out of the void. I mean, how did he pop out of the void?
We're going to leave it there, Coffee. We are running out of time. Just 30 seconds to respond to that one, Chris.
Yeah, I don't really change my opinion, which is that because someone has come up with a model to explain this is a model informed by the laws of physics, which, to our knowledge, extend across the universe, and so they're ubiquitous. So using those laws of physics, we can understand and make predictions, which we can test. We know they work, and this means we then refine our understanding of things based on making predictions, testing those predictions, finding they work, and the models we have built in that way are that planets form the way I've suggested that they do.
Chris, thanks for sharing your wisdom with us. Have a wonderful weekend.
Have a good weekend, everyone. Bye-bye.